with our sets today, and we are going to talk about some counting techniques. So section 7.3 is today, and it says counting techniques is a method for determining the number of elements in a set without counting them one by one. Basically, just means we're going to have some formulas that will help us shortcut the process. The first one we're going to look at is when two sets are disjoint, meaning that there is no overlap between them. So if I were to draw their Venn diagram, here's circle A, here's circle B, and they are completely separate. There is absolutely no intersection. There's no overlap. These are called disjoint. When they are disjoint, all you have to do is add the two amounts together. So if you want A union B, you just take the number of elements that are in A and add it to the number of elements that are in B. So the example I give you is A represents there's 14 females, B says there's 21 males. What is the number of A union B? And basically asking, what is the number of males or females? So this is asking, what is the number of, if I put it in order here, females or males? You cannot fall into both categories. So there are 14 in the first group. There are 21 in the second group. So all you have to do is add them together to make a total of 35. Now, all the ones that we worked with had overlaps, had intersections where A and B shared something in common. So this is also called the general addition principle. It is when we do not have disjoint sets, and when we want to find the union of A or B, we take the sum of A plus the sum of B minus their overlap. And I'll explain with an example why this works this way. So if we have A is the numbers 1, 2, 3, 4, 5, and B is the numbers 1, 3, 5, 7, 9. Find the number of elements that are in A or B, A union B, or I could read it A or B. So if I just did the formula, it says the number of elements in A plus the number of elements in B minus the number of elements in their intersection. So this is what they share in common. A has a total of 5 elements. B also has a total of 5 elements, right? There's 5 numbers in A, 5 numbers in B. Now, what did they share? They both have a 1, they both have a 3, and they both have a 5. So there are 3 in common. So 5 plus 5 is 10. 10 minus 3 is 7. Now, if you don't like this, you always have the option, to go back and draw your Venn diagram. And I always start with what's in the middle. So what's in the middle is 1, 3, and 5. I also have a 2 and a 4 inside of A. B also has a 7 and a 9. So it's asking how many numbers are contained between A or B. Well, if I count them, 1, 2, 3, 4, 5, 6, 7. There are 7 pieces right there, same number. Third option. You could write A union B like we did last class. So this is everything in A combined with everything in B all in one set of brackets. So 1, 2, 3, 4, 5. I already have 1. I already have 3. I already have 5. I need to add 7 and 9. And then I could count them from there. So 1, 2, 3, 4, 5, 6, 7. So it doesn't matter how I do it. The answer is 7. The reason the formula works the way that it does is because if I add all of these, there are 5 of them here, and then I go and add these 5, the problem is that I've counted those 3 in the middle twice. I've counted them in circle A, and I've counted them in circle B. So what I have to do is I have to subtract out a set of duplicates. That's why this formula works the way that it does. All right. The point is, when you come across a word problem like this, you don't have to necessarily draw your Venn diagram. We can just use the formula. So the survey shows 345 firms offer life insurance, 285 offer disability, and 115 offer both. Okay, so if I'm reading this, the 345 is the number that offers life. 285 is the number that offers disability. So I just pick the first letter and I put it in there. And then for both means 115 is the number that you have to have both of them. That's the intersection. So L intersect D. So both is your intersection. When you want the or, that's the union. So this is asking L union D is my question. And we have our formula. So the number in the union is the number in L plus the number in D minus the intersection. So I'll take 345 plus 285, and then I subtract 115 from that. And that is going to leave me with 515. Okay, could I have gone and drawn the Venn diagram? Yes, I always like to show you multiple ways here. I always start with the intersection. There's 115 in there. Now, inside circle L must sum to 345. I must have a total of a 345 inside circle L. I have 115 already used. So 345 minus 115 is going to tell me how many are just in the life section. I think that's 230. And then I could have done the same over here for disability. There should be a total of 285. So 285 equals 115 plus what? So I subtract the 115. What's left is 0, 170. Then I would take 230 plus 115 plus 170, and I would get that same answer. So if you have a way that you prefer, like if you honestly love Venn diagrams and you want to do it that way, that's totally fine. This is technically a little faster, but either one will get you to the same answer. Students at a university have an option to stream TV or watch cable. A survey of 100 students showed that 65 stream, 45 watch cable, and 30 did both. Once I get to a multi-part question like this, for me, it's easier to just create my Venn diagram so that when I'm answering each part, I already have all the numbers in place. All right, so I know my box should equal a total of 100. I've got streaming and I've got cable. I'm going to start in the middle. 30 have both. Inside the stream circle should be 65. So 65 needs to equal 30 plus what? 35. Right? So 35 and 30 make a total of my 65, which is in my streaming circle. Perfect. I can do the same with cable. Cable should equal 45. Currently, I have a 30. 30 plus what gives me 45? 15. All right. So I have a total of, let's see, what do we have? 35, 30, and 15. Right now, my total is at 0. Carry the 1. 4, 5, 6, 7, 80. But I need to have a total of 100. So how many am I short? 20. And where's that going to go? Outside in the box. Yes, either of those make sense. Okay. So how many streamed only? That's the first value we found. 35. How many watched cable only? That's the second value we found. 15. How many didn't watch any TV at all? And that's the last value we found, our 20. Survey of 200 people found that 80 owned a cat, 55 owned a dog, and 23 owned both. Again, a multi-part question. Generally, I will draw my Venn diagram. If it was just asking you one part, I may not draw it. All right, so our box should equal 200. I got cats and I got dogs. We start with the middle. 23 had both. All right, so my goal is to get in my neither, what's outside here. So cats should equal 80. And I currently have 23. So 23 plus what gives me 80. If I subtract that out, 57. Do the same with my dogs. So dogs is 55, which needs to equal 23 plus what? Subtract out the 23, leaves me 32. Okay. Other thing I could have done on the side here is I could have taken the A union B, just to show you the difference here. 80 plus 55 minus 23 is going to give me 80 plus 55 minus 23. 112, and that's in the circles. Right? If I can spell. And if I know I need to have 200 total, I could just take the 200 minus the 112. And that leaves me with 88. So A is 88. In the end, I still needed to find this value here. How many owned a dog, but not a cat? So when you think about it logically here, this circle contains all the dog owners, right? However, this portion is dog and cat owners. Remember that intersection is the and statement. So this is dog and cat. So if we only want dog, that's this here, only dog. And this very here is only cats. So only dogs, 32. And if you're curious, just for it. So this could be written, the number of dogs minus cats like this. So dogs not including cats. So take dog total, subtract out the part that's in the cat section. It could also be said the number of dog intersect not cats. So dog and not cats. Those are some other ways that you could actually see the symbols written. Okay, so then I'm going to go to one other concept we're going to talk about here, which is called the multiplication counting principle. And basically what's happening here is we are making a sequence of choices. And what I need to do is I need to multiply the number of possibilities of each choice all the way through. So if n operations, O1, O2, O3, so on and so forth, are performed in order with the following number of outcomes, N1, N2, N3, so on and so forth, then there are N1 times N2 times N3, so on and so forth, a number of outcomes. So an example here says you have 20 shirts, 15 pants, and 14 shoes that can all work together to form an outfit. How many outfits could you make? So here's what we're doing. In order to leave the house, I need to have a shirt on. I need to have a pair of pants on. And I need to have some shoes on. Right? I cannot get into any public building without shirt, pants, and shoes. Well, there are 20 shirts. There are 15 pants. And there are 14 shoes. All I'm going to do then is multiply across my sequence of events or sequence of choices. I actually don't have this one on my paper here. Nope, 20 times 15 times 14, 4,200 unique combinations of outfits. Just so that you're like, holy cow, that's a lot. Uh-huh. Now, part of that is literally having the same shirt and pants and just picking different shoes each time. So, but the thing is, like, if you add other things to that, how much more you could have. So if you're a girl and you say, okay, well, I want to pair some earrings and a necklace, that changes and increases even more, right? If instead of like pants, you also include shorts and skirts, like, again, that increases so many more options that you actually have in your closet, but you probably pair the same clothes together just because we're creatures of habit. A particular new car model is available with 5 choices of color, 3 choices of transmission, 4 types of interior, and 2 types of engine. Okay, this is like basic here. I'm just giving you an example of how we can figure out how many ways we can build these cars. We know in cars, there's also like trim level packaging. There's add-ons like, do you want a sunroof? Do you want the sound system? Do you want remote start? Do you want theft security? Do you want, like, there's all these other things that you can add on to a vehicle. So we're simplifying it here. We have color, transmission, interior, and engine. So using only those 4 things, 5, 3, 4, 2, if I multiply all those across, that alone is 120 different cars. Have any of you actually gone car shopping? Okay. How likely are you to walk on and them have exactly what you want? They don't, right? You're shaking your head. No, because there's so many options here, right? If you're the person that then also wants, you know, the sunroof, or I want this added to it, you may have to custom order the car, because what a car company is doing here is they're taking the most common color, automatic transmission, more than manual, because more people drive automatic, and they're going to put those things on the lot because this is what more people are generally geared towards. But you can see then, if you're somebody who has specifics that I want to make sure I want this model, I actually got really lucky that when we bought my Jeep, we actually found one that had everything we wanted. A small combination lock. Note, a combination lock is actually not a combination. So we call it a combination lock, but it is actually a permutation lock because the order that you put the numbers in matters, right? If your code is 32, 15, 6, you have to put them in that order. I can't change the order up. All right, so it has 3 wheels, each labeled with the 10 digits, 0 to 9. How many 3-digit combinations are possible? So this is kind of like those old school briefcases that had like the 3 little dials on it. Some of you that are younger may have absolutely no idea what I'm talking about right now. But some of the little locks on like luggage used to have that. It was like 3 little wheels, and you could pick your 3-digit code. So number 1, number 2, number 3. There are 10 digits, 10 single digits. We work in a base 10 system. The numbers 0 through 9, there are 10 of them. So I have 10 choices for the first slot, 10 choices for the second slot, and 10 choices for the third slot. And I realize I'm answering the second question first. I apologize. So this is repeated. I skipped the first one. Okay. If digits can be repeated, that means I can have 111. I can reuse the number. So that is 1,000 different possible combinations. So let me go back and do the first question here. It says, how many 3-digit combinations are possible if no digit can be repeated? So no repeats. Number 1, number 2, and number 3. So my first digit can be entered in, and I can use any of my 10 digits. However, once that is chosen, I cannot use that number again. So how many remaining numbers do I have for the next slot? 9. Now I filled in 2 numbers. How many do I have for the next spot? 8. Beautiful. So 10 times 9 times 8, that drops it down to 720 different combinations, aka permutations, because order does matter. All right, so the last one says, how many 3-digit combos if successive digits must be different? Successive, different. So that just means the number, the second number you pick can't be the first number, and then the third number can't match the second number. So we still start with 10. Number 2 can't match number 1. So I'm down to 9 choices. Number 3 can't match number 2. It's got to be a different number than number 2. I only put 1 number in there, so that still leaves 9 other potential options. So if I put a 1 here, I can use 0, 2, 3, 4, 5, 6, 7, 8, 9, right? And that one is 810. Yeah. So let's say I put 5 here. This cannot be 5. So that means there's still 9 other potential numbers, right? Could be 0, 1, 2, 3, 4, 6, 7, 8, 9. There's 9 possibilities there. I have 10 choices here. Whatever I put in here, this one can't be that number. So not number 2. Number 2 is only one option. So it's specifically saying successive digits have to be different. So this has to just be different than the one before it. So whatever I put in there, there's still 9 other remaining options that can go there. How many 2-letter code words can be formed from the first 3 letters of the alphabet if no letter can be used more than once? Okay, I always like to write little blanks and fill them in. So 2 letters. I want to fill in 2 letters. I have 3 letters to choose from. The first 3 letters, A, B, and C, but I cannot repeat a letter. So first spot has how many choices? Okay, if I cannot repeat, the second slot has how many choices? 2 for a total of 6. Okay, that would be AB, AC, BC, BA, CB, and CA. Those are the 6 two-letter codes. Number 9, and these are all from the section of the book. So if you are curious, it is from section 7.3. I can find the page number that it starts on. Just had it open. So it starts on page 374. So it's either from page, these are both from page 374 of your e-text. If you don't want to write the whole problem down. A coin is tossed with a possible outcome of head or tail. Then a single die is tossed with the possible outcomes 1, 2, 3, 4, 5, or 6. How many combined outcomes are there? So that means we are flipping a coin and we are rolling the die. Our coin has 2 options. A single die has 6 options. Multiply for a total of 12. Just to show you, head 1, head 2, head 3, head 4, head 5, head 6, tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. Those are all 12 my possibilities. Look familiar from statistics for those of you that took this before? An entertainment guide recommends 6 restaurants and 3 plays that appeal to a couple. If the couple goes to a dinner or a play, not both, how many selections are possible? So the key word here is or. Or implies addition. So I can go to dinner or a play. There are 6 dinners, 3 plays, or means I add them for 9 different potential dates. Now, B says if the couple goes to dinner and a play, keyword and, it means I'm going to multiply. So dinner and a play means 6 times 3 to get 18. So the key for these is you just have to read them carefully. A college offers 2 introductory courses in history, 3 in science, 2 in math, 2 in philosophy, and 1 in English. If a freshman takes 1 course in each area, so she's taking something from every single section, how many ways is it possible? So she's taking a history, a science, she's taking a math, a philosophy, and she's taking an English. She's taking one of all of those. So we just fill in 2, 3, 2, 2, 1. So she's taking history and science and math and philosophy and English, multiply all the way across. 6 times 4, 24. If the part-time student can only afford to take only taking 1 course, how many selections are possible? So now she's taking history, or she's taking science, or she's taking math, or she's going to take philosophy, or she's going to take English. So for this one, we would add them all together. 6, 7, 10. We have a 2-way table. And this is still in your book, but problem number 61 is from page 376. So what we have is we have different age groups. We have totals. And then it's broken between males at minimum wage or males below, females at minimum wage, and females below. Okay, so question A, how many males are of age 20 to 24 and earn below minimum wage. So they have to be a male, below minimum wage, and they have to be in this age group here. Okay, here's the males, below minimum wage. Here's the age group. It has to fit both of those pieces. So that's 102. Oops. Apparently I'm still on highlighter. And, oh, this does say in thousands. So add my 3 zeros, 102,000. Okay, next question. How many females are age 20 or older and earn minimum wage? So female minimum wage, I'm working here. This is 16 to 19. That doesn't work. 20 or older. So this one and this one both work for that. So 186 plus 503 to 689. 0, 0, 0. Letter color. All right, how many workers are of age 16 to 19? So 16 to 19. All right, so here's this 16 to 19. All of these guys. All of them. Or males earning minimum wage. So males earning minimum wage, here's their total. Okay, so this is an or. I'm going to take this column plus the row, but do you see there's an overlap value? Right here. So 1079 is the total of 16 to 19. Males is 379 total, but I need to subtract the 118. This is faster than taking 343 plus 118 plus 367 plus 251 plus 102 plus 159. I could have added all 6 of these numbers together to get this answer, but it's faster to work with 3 numbers. So total plus total minus overlap. And that will leave me with 1,470, but I need to add 3 zeros. So that is 1,470,000. And then D is asking how many workers earn below minimum wage. So below minimum wage is this. Female below minimum wage is that one. So then I can just add those 379 plus 993 is 1,372. Add the 3 zeros. So 1,372,000. All right, got 2 more problems. And then you guys have your quick check and we'll be done for today. Family planning. A couple is planning to have 3 children. How many boy-girl combinations are possible? Distinguish between the combined outcomes such as boy-boy-girl, boy-girl-boy, and so on. So first is solve using a tree diagram. All right. So I'm going to show you how we could do this. So at the beginning, your first child can either be a boy or a girl. So here's first child. Okay, second child. Could be boy or girl. Repeat down here, boy or girl. Third child can again be boy or girl, girl, boy or girl, boy or girl. Okay, so then how do I follow the results here? Well, I'm going to follow all the paths. So boy, boy, boy is that top path. Boy, boy, girl is that second path. So I went boy, boy, boy. That got me there. Boy, boy, girl. Got me that one. Okay, so the next one, boy, girl, boy. Boy, girl, girl. I thought I was on highlighter. Clearly not. Okay, going down. Girl, boy, boy. Girl, boy, girl. Girl, girl, boy. And my last one. Girl, girl, girl. Okay, this is my total over here. 1, 2, 3, 4, 5, 6, 7, 8. Now, that's a lot of work. I could have just gone like this and said, first child, 2 options, second child, 2 options, third child, 2 options, 2 times 2 times 2 is that same 8. All right, last one here. A group of 100 people touring Europe include 42 who speak French. So the number of French is 42. The number of German is 55. And 17 who speak neither. So the number of not F or not G is 17. So they're not in circle F and they're not in circle G. Actually, is that supposed to be the intersection? Circle F, circle G. So not F. Yeah, that's gotta be the intersection symbol. Okay, so walk with me quick here. If I had F, G, and intersection, right? The number in F union G is the number in F plus the number in G minus their overlap. Okay, this gives me the total that's in the circles. This value's outside here. So if I take the number of F union G plus this number that's outside, I'm going to get the total. Okay, so what I want is the number in F plus the number in G minus the number, sorry, these are in the intersection, plus the number in the outside equals the total of 100. And then we're just going to solve for the one we're missing. So it's literally, there's 4 pieces. F plus F plus G minus intersection plus outside equals total. So FG minus intersection plus outside equals 100 equals 100. So 42 plus 55 minus, this is the one I don't know because it says how many people speak both. That's the one I'm trying to find. Plus 17 equals 100. All right, so if I add those all together, 42 plus 55 minus 17. No, plus 17. What am I doing? 42 plus 55 plus 17 is 114. 114 minus x equals 100. If I subtract 114, I have negative x equals negative 14. So x is positive 14. So if we double check, 14 here, 17 on the outside. So let's see, should be 42 total in the circle. If I've used 14, that leaves 28. 55, take away 14 is going to leave me 41. Does that work? 28 plus 14 plus 41 minus 7 plus 17. 28 plus 14 plus 41 plus 17 gives me my total of 100. Yep, I did it right. Quick quiz for today. It is 2 questions. And make sure you follow all the parts. Says a group of 75 people includes 32 who play tennis, 37 who play golf, and 8 who play both. So number 1 is create the Venn diagram of the situation. The next 3 are how many questions. And for each of those 3, I want you to write it in symbols based off of what letter you give something. So if you're making golf G, tennis T, and I say, what's the number of tennis only? NT. So I want you to write that in symbols and also solve. So when it says how many students play neither sport, write it in symbols and then solve it. So I want to see number of whatever it is equals. So it's 1 point for each. How many play tennis or golf? How many do not play golf? So remember our choices are, so you could have like a single letter. This is the complement or not something. This is intersection, both and. Union is the or. And then the outside, we did F naught intersect G naught. That's the outside of the circles. You could also write that the number F union G naught. So F union G is everything inside the circles. So not outside of that means everything outside of the circles. There's usually more than one way to write these different things. But that's kind of what I'm looking for. All right, then the second one is one like we just did. So a high school football team with 40 players includes 16 who played offense last year, 17 who played defense last year, and 12 who were not on the team previously. How many players from last year were on both? So we're looking for that intersection piece.